What is up, everybody? So today we are looking at polygons. So we're moving away from triangles and we're going to figures that have more sides, right? We've been stuck in triangles for a long time. It's time to progress on. So let's quickly review what a polygon is, right? So remember, a polygon has straight sides, there's no openings, and there's no intersecting of more than two sides at any time, right? So we're not going to have like these crazy diagonals crisscrossing through our figure. And so this is an example of a bunch of polygons, right? Remember, we name polygons based off their number of sides. So that first one is a triangle because it has three sides. The next one's a quadrilateral, 4 sides, 1, 2, 3, 4, 5, 6. The next one would be a hexagon, and then finally 1, 2, 3, 4, 5, 6, 7. 7 sides would be a heptagon. Now today we're focusing on the interior and the exterior angles of polygons. And so remember, guys, interior angles are all the angles that are inside your figure, okay? And exterior angles are formed by extending a side. So if I looked at that triangle and I want to extend one of these sides right here, this angle right here would be an exterior angle. And because I have 3 interior angles, that means I'm going to have 3 exterior angles as well. And then the last thing before we move on to some new stuff is notice that the relationship between the interior and the exterior angle. Angle 1 is our interior angle, angle 2 is our exterior angle. They are supplementary. So no matter the shape, no matter how many sides, no matter if it's regular or not, the interior angle and the exterior angle will always be supplementary, adding to 180 degrees. Okay? Now, what I want you to focus on, right, is let's look at this triangle. Now, we know that no matter what type of triangle it is, whether it's right, acute, obtuse, scalene, isosceles, equilateral, that angles 1, 2, and 3 have to add to 180 degrees. Because we know that all triangles, interior angle sum is 180 degrees. Okay? So that one's easy. But now when we look at the quadrilateral or the hexagon or the heptagon, that interior angle sum is going to change. The more sides that we have, the higher our sum becomes. And it's all based on how many triangles can be made in your diagram. So if I look at that quadrilateral, if I were to draw a diagonal there, I have 2 triangles. If I draw a diagonal here, again, I have 2 triangles. So I would know that this triangle's sum would be 180, and I know that the other triangle's sum would be 180 degrees. So that means that their interior angle sum would be 180 plus 180. Now, let's look at the next figure. And again, guys, you cannot crisscross your diagonals, and you usually want to always draw them from the same vertex. So if I look at this here, for the hexagon, I have 1, 2, 3, 4 triangles. Well, all 4 of those, their sum would be 180, so it would be 180 plus 180 plus 180 plus 180. And finally, for our heptagon, 1, 2, 3, 4. So I'm drawing 4 diagonals, 1, 2, 3, 4, 5, but I actually have 5 triangles. So let's look at this. This has 3 sides. It has 1 triangle. This has 4 sides. It has 2 triangles. 6 sides, 4 triangles. 7 sides, 5 triangles. So we got to think, what is the correlation to the number of sides to the number of triangles that you can create? It's always just the number of sides minus 2. That's how many triangles you're going to be able to create by drawing in these diagonals from the same vertex. Okay? And so focus today, interior angle sum, exterior angle sum. So the interior angle sum, like we've already talked about, is the sum of all the interior angles of a polygon. Okay? So the sum of all the interior angles of a polygon. And it all evolves around how many triangles are being created within your figure, right? So we can use this formula n minus 2 times 180. So this is a big formula to remember here. N is the number of sides. And what this is doing, this first part of this formula right here, this n minus 2, all it's doing is figuring out how many triangles can be drawn within your polygon. And then that number gets multiplied by 180, and that gives us our interior angle sum. Very straightforward, very simple. It's the only formula for today. N minus 2 times 180. Okay? And so the reason that this is important, guys, and the majority of the work we're going to be doing is with regular polygons. So remember, a regular polygon is all angles and sides of that figure are congruent. So like an equilateral triangle is regular, right? Because all three sides are the same length and all three interior angles are 60 degrees. Okay? So let's jump into a couple example problems right here. So interior angle sum. So if I wanted to find the interior angle sum of an octagon, well, I know that an octagon has 8 sides, so my n would equal 8. So it'd be 8 minus 2, whatever I get, times 180. So 8 minus 2 is 6. 6 times 180, that is 1,080 degrees. So my interior angle sum of an octagon, it doesn't have to be regular yet, we're not to that point yet, is 1,080 degrees. And all I had to do is use that formula, n minus 2 times 180. Now this can be done with much bigger figures, right? It's like a 16-gon. That's 16 sides. So my n equals 16. So 16 minus 2 times 180. That's going to be 14 times 180. That gets me 2,520 degrees. Pretty straightforward. As long as you know the formula, this is pretty easy, right? Okay. Now, what if we're going to talk about the exterior angle theorem? Now, let's look at a couple polygons again. Now, when I extend the sides, you always want to try to extend the sides going in the same direction. So I'm going to go clockwise. So I'm going to extend here. I'm going to make an angle right here. I'm going to extend another side and another side. So again, notice that I messed that one up. I'm always going in the same direction. It doesn't matter, you could have gone the other way and this still would have totally worked, but that's just the direction I chose to go. Now imagine that this was a regular triangle, so this would be 60, 60, 60. Well, we know that exterior angles and interior angles are supplementary, so that means that this would have to be 120, 120, 120. What's 120 plus 120 plus 120, or 120 times 3? It's 360 degrees, okay? Now imagine we go over to this quadrilateral. I'm going to extend my sides again. So I have my exterior angles one more time. Now I'm putting the same number of arcs, but that doesn't necessarily mean that they're all the same measure. It's just for diagram purposes. Okay. Now let's say that this is, we know that a quadrilateral, that'd be n minus 2 times 180, that's 2 times 180, that's 360. So all these have to add to 360 degrees. Okay. Now let's say that this angle is 120, this angle is 120, which would mean that these would each be 60 degrees. Okay, 120 plus 120 plus 60 plus 60 is 360. Now let's look at this though. 60, 120, 60, 120. These four angles, even though our interior angle sum is larger than in our triangle, our exterior angle sum is still 360 degrees. Okay? And that is because no matter how many sides the polygon has, the exterior angle sum is always 360 degrees. It will never change. Okay, so where interior angle sum gets larger the more sides you add, the exterior angle sum for any polygon, whether it's a triangle or a 30gon, is always 360 degrees. Interior angle sum. So this is just a couple of examples, guys. So let's say that interior angle sum equals 900. How many sides does the polygon have? So we know that our formula n minus 2 times 180 equals our interior angle sum. Well, if our interior angle sum is 900, we can just set up our equation like that. And then the goal here is to solve for n. So I can do 900 divided by 180. That gets me 5. So that n minus 2 equals 5. I add 2 to both sides. So the number of sides is 7. Okay. And then our last example says find the measure of the interior and exterior angle of a regular hexagon. Now my advice is it's always easier to find the exterior angle first. Okay, so I know that it's regular. I know it's a hexagon, so that means that I have 6 sides. Now if it's regular, that means all the interior angles are congruent. Well, if all the interior angles are congruent, then all the exterior angles are congruent as well. There are the same number of exterior angles as there are interior, and the same number of angles is the same number of sides. So if a hexagon has 6 sides, it has 6 interior angles and 6 exterior angles. So what I can do is I can do my exterior angle sum, which is 360. I can divide that by 6. So 360 divided by 6 is 60 degrees. So that is my exterior angle. That's just one. Once I know the exterior angle, I can just do 180 minus that amount, and that gives me my interior angle. Because remember, exterior and interior angles are supplementary. And just to show you how it can work for a 20gon, okay, again, it's a regular 20gon, so I can just do 360 divided by 20. That gets me 18. So my exterior angle is 18 degrees. Then to find my interior angle, let's just do 180 minus 18. That gets me 162, and that is my interior angle. Okay, try to make this video short. Please let me know if you have any questions.